thanks for the pillars that we prepared for the next sessions. Please let us know if you have any question for the previous presenter. Just feel free. You can ask any questions. All the presenters still here.
Can you see my screen?
Yeah, you can see your screen. Anytime you are ready, we'll switch to your screen.
I'm presenting right now. You're able to see the screen, right?
Yeah, you're able to see your screen. Your voice is okay. So you're ready. You want to present now? You want to wait until the time we have?
Let's give a couple of more minutes for other people who might be joining from the other tracks.
Okay.
We start at 12:05.
Right. So, Anson, can you share what is your experience of using the Azure Sentinels, the implementation? What's the difficulties that you have? Maybe the audience want to understand. Oh, Anson is not here. Okay. Okay, Nilesh, while we are waiting for the attending, can you share roughly what is the session about?
Okay, so I'll be talking about Azure Functions and containers, so serverless in general on the Azure platform, how we can use different serverless technologies, and how does container come into the picture when we talk about serverless. That's the topic of my session.
Okay, so is there any difficulties when you use this one? I mean, what are the challenges and what are the key that we solve using this serverless?
The key is the way we manage the code and the infrastructure. So if you see the trend nowadays, people are moving more and more away from managing their infrastructure and moving to cloud and focusing on business functionalities. So that is where things like Logic Apps and Azure Functions come into the picture. And that allows you to integrate with other services and SaaS platforms quite easily, and it allows you to have that agility into your business processes.
Okay, excellent. Okay, very interesting, guys. We wait for the session to start
Two
and
more
for
minutes.
other people to come. Yeah, 2 minutes.
Okay, we are good to go.
Okay.
Okay, hi
Over to you.
everyone, welcome back. So today I'll be talking about the serverless functions. or serverless containers. My name is Nilesh. I'm a Microsoft Azure MVP. And let's look at the agenda, what we have on this session today. So we'll focus with understanding what's serverless or how does serverless come into the picture. Then we'll look at what Azure has to offer in terms of serverless. So we'll look at logic apps and Azure functions. And then we will look at how we can incorporate this into serverless containers using the Azure Container Instances and Azure Kubernetes Service. So let's look at evolution of the application platforms over the years. So if you look at last 10, 15 years, we have moved from maintaining our own infrastructure in data centers on premise to cloud. So the initial step when the cloud started was moving about your infrastructure or the VMs to cloud, that is infrastructure as a service. Then after some time, people started offering different platforms as a service. You had database, you have containers, you have the IIS servers or web servers offered as the platform. So you don't again manage the infrastructure. You get the whole platform and you start using that in your applications. And of late, we have seen a lot of surge in serverless. So people are moving away, not away, I would say a combination of PaaS as well as serverless. So what really is serverless? Serverless is combination of three things, I would say. First one is the abstraction of servers. So when we talk about serverless, it doesn't mean there are no servers. There are definitely servers running in the background, but the point of focus shifts from managing the servers to focusing on what you really need as a business process or what you need to build as a functionality for your application. So you spend more time and resources on developing your business rather than focusing on maintaining the servers, updating, patching, and stuff like that. Serverless also focuses on event-driven and scale. So if we look at past, people would buy huge hardware in anticipation that maybe 1 year down the line, I would have this much request coming in for my application. And then when you went live, you would realize that resources are not effectively used. So that is another problem which serverless tries to solve by being more event-driven and by allowing us to scale when the need is there. And third one is micro billing. So since we are scaling on demand, our billing is again related only to the resources that we use and not like we are provisioning resources and we are just keeping them idle for a while. So let's look at the serverless offerings from Azure. We start with logic apps. Logic apps allows us to design workflows and orchestrate processes. So if we need to integrate with online services, if we want to pull data from one system and store it in a database, and the processes are quite simple, then we can use logic apps to build these kind of applications. Functions, they allow us to execute code based on certain events. So when we talk about this, we also need the supporting environments and as well as the support for developers. And in the Azure space, we have additional features which enable us to do all this. So from development point of view, we have the IDE support within Visual Studio or Visual Studio Code. There are integrated development environments, and there's also support for DevOps practices. There is support for local development. Since these are running on cloud, we don't need to run everything on cloud every time. During the development, we can test and do the development locally. And it also supports monitoring and debugging. And we also have support for cloud services like database, storage, security, IoT, analytics, intelligence. All that is supported as part of these platforms. So let's look at Azure Logic Apps first. Doctor. Hello? Somebody's mic is on. Am I audible? Hello? Are you guys able to hear me?
Yes, we can hear you.
Okay.
You're audible.
Okay, thanks. So the first thing that Logic Apps offers us is a fast integration using a visual designer. And if we need a workflow creation based on some triggers and action, we can use this. It also allows us to connect to applications, data, and services, and to orchestrate and to connect to Azure Functions. So let's look at a demo of the Logic app. So this was one of the scenario which I was facing personally, and I built a Logic app to automatically reply to certain kind of emails. So I was having uh, account with a bank, and unfortunately my email was linked to some other account, and I was getting continuous emails from the bank saying there is credit card due for my credit card. I was being pestered by the bank almost every week, 2 or 3 times, saying this is due. And I tried going back to my relationship manager and tried to explain that the account doesn't belong to me. But even after 6 months, this didn't stop. So I got fed up and I built a Logic app which looks at my Gmail every day, and it sees if there is an email coming from this particular email account and the subject matches to a particular subject line. And if I found a match, I would respond back to the bank and my relationship manager asking why am I still getting this email. So let's look at this, how I built it. So is the video visible to guys?
Yeah.
Okay. So this is the Azure portal. I'll first start with how do we build a Logic app. So you can go into new and create a Logic app. And like all other Azure resources, we will get the option to either create a new resource group or use an existing resource group. Give the name for Logic app, and then select the region where I want to deploy this. I can also enable log analytics and then create and review. So the step to create the Logic app is quite simple. So let me go straight into the Logic app that I have built. So in this app, currently, I have disabled it because after running this for about 2 or 3 months, the bank took action and the email stopped. So I have this option of enabling and disabling the app as and when it's required. So let's look at the designer of the Logic app. So here I have 3 different stages for the app. First one is the recurrence or the trigger. I've set this interval as 1, and I can choose either daily, weekly, or every hour, every minute, what frequency this app should be triggered. Then is the
Hi,
integration.
Raywood, can you please mute yourself? Everyone getting echo now. Yeah.
Hello.
I think the remote is not muting himself. That's why everybody getting echo now. Can you please mute him?
Hello. Is it better now?
Yeah, it's good now. Yeah.
Okay. Sorry about that. So the next step is I look at, I've integrated with Gmail, and I look at my inbox folder. I look at from the sender and the specific subject that I'm looking for. And I can also look at the dynamic content. So when I reply or when I even look for the incoming ones, I can click here and you can see I can pick any of the dynamic content from the email. So I'm using the sender and the body of this message, and then I specify CC of the email and the recipient of the email. So if you want to add, let's say, any other step, so what you get out of the box is all these features. So let's look at some of the built-in triggers and the actions. So we have HTTP trigger, inline code, Azure Functions, Azure Management, and this is just a small set actually. We will see in a short while that the list of items or the list of supported connectors is quite huge. So depending on which trigger we select, the action for that particular trigger would be different. So now you see here in the standard connectors, when I expand the list, there are actually 7 columns in each row, and you can do the math, how many connectors are supported as I scroll down. So you have support for social media sites, you have blogging support, you have SaaS applications, the enterprise applications, your project management tools. Almost everything is covered as part of these built-in connectors. So all you need as a user or as a person building Logic app is access to these tools. If you have an account with these providers, you can use those services as part of your Logic app. And even for the enterprise, we can see here IBM MQ and other services are supported. So once we have built the Logic app, from a CI/CD point of view, we can also look at the code which is generated in the background as JSON, and we can extract this, put it in the source control, and we can have continuous integration and continuous deployment using the code in your source control. So that was the demo of Logic app. Let's move on with the rest of the presentation. So in terms of the connectors, we saw that it has support for all the cloud services like Functions, Service Bus, Cognitive Services, also SaaS services, and we can also connect to on-premise sources. So you can think of connecting Logic app to almost everything. Next, we look at Azure Functions. So functions are basically your code and some event. So think of it like you want to execute a piece of code, but you don't want to manage the environment. And that is where Azure Function would come into the picture. So why Azure Functions? Azure Function supports multiple languages. So now with more and more people using microservices, we see that there is polyglot development happening. So we're not restricted to one programming language per application. One application can have multiple microservices, and each microservice can be written in a different technology stack. So from that point of view, Azure Function supports C#, it supports Node or JavaScript, Python, F#, PHP, PowerShell, all this. It also has support for NuGet and NPM packages, so you don't have to write all the code yourself. You can bring in or import these packages, which might be available publicly. And you can also run your own custom DLLs or executables, which you might have built previously. So there are two main things which work with Azure Functions. One is the trigger. And currently, we have support for blob storage, Cosmos DB, event hubs, HTTP triggers, queues, service bus, timers, and webhook. And then we have bindings. So bindings are what binds the code or what actions we want to take based on these triggers. So in terms of binding, we have file bindings, table, Excel, and the other bindings which are listed here on the screen. So let's look at some of the scenarios where we might want to use function. So let's say you have web sessions which are stored in database and you want to purge them every 15 minutes. So in this case, we can have a function which is triggered based on a timer. Every 15 minutes, the function would be triggered and we would clean the invalid data from the database table. The other one is when we have a file added to a blob storage and we want to transform, let's say, a CSV file into a table and then show it on a Power BI desktop application or Power BI dashboard. So typically in the past, we would have built like a Windows service running in the background and we will have to keep it running to handle this kind of scenario. So now we can have a trigger which is based on the action of adding a file, and we can have this come up only when the file is added and we don't have to keep the Windows service running all the time. Next scenario is, let's say we have a photo taken like an Instagram or some application. There is a webhook which is called, and this data is stored in blob storage, and we want to have thumbnails which are of different sizes, let's say small, medium, large. So we want to scale those images for different form factors. So we can use a function app for doing this. It can also be used for websites in case of personalization. So let's say a user logs in, and for a logged in user, there are preferences. So based on the preferences or user profile, we can base the ads, we can target the ads, and those can be served to that particular user. So this can help in building a case which is based on personalizing the experience for the end users. So the example which I'm going to show today for Azure Functions is again one which I use personally on my Azure subscription. So in the past, I used to have many demos created on my Azure subscription. And once I created a demo with HD Insight cluster, slightly powerful one, and I forgot to delete that demo cluster. And it almost wiped out my credits for the subscription. So what I did was to come up with a function which runs every day, and it looks at the resource group within my Azure subscription. If there is a prefix on the resource group which says delete me or demo, this will go and delete the resource group for me. So after a while, on a daily basis, I would have all these demos cleared, the resource groups and the resources for that demo will be cleared. So let's have a look at this particular demo. Okay, so let's first start by looking at how do we create a function app. So again, we start with a resource group. Either we can use existing or create a new one. We give a name for the function app. And in terms of publishing, we can publish it as a code or as a Docker container. We need to select the runtime on which we want to run the function. So in this case, it has support for .NET, Node. We have 2 versions of Node supported. In case of Python, there are 3 different versions of Python supported. When it comes to Java, there is Java 8 support. And in case of PowerShell, there is PowerShell core, which is 6 supported. Then we select the region, and we can choose different hosting models and the plan that we want to execute the function. So by default, it's the consumption-based plan, which is the serverless. But we can also choose to have a premium and app service-based plan. So in this case, the function would be deployed into a particular app service instance, and we can choose the size. It can be a dev test kind of sizing for the VMs, or it can be a production grade size. And once we choose which size we want, this function which we are developing would be deployed into that plan. We can also choose the operating system, either Windows or Linux. And since I selected PowerShell core, only Windows was applicable. But if I choose the runtime environment to something else, I will be able to select Linux as the operating system. So here I have again pre-created that function. So let's look at the function which is doing the auto deletion of the resource groups. So we can see that there are multiple settings which are applicable or available for the function app. And we can restrict the quotas on how much resource is used on a daily basis. And if the quota is over, that function would be stopped from executing for until the next day. In terms of platform, we have integration with various other services like networking, API, monitoring, development tools. All this is integrated into the environment. So let's look at the code of the function. So since it's a PowerShell function, here it's taking a timer as an input, and then we run the PowerShell command, which is to get the resources, and we are filtering if the resource name or resource group name is containing a prefix delete me or demo. And if there is any resource found, it will go and delete it. We also have, from a development point of view, support for logs and console. And we can also look at the files on the right-hand side, which are part of this function. Next is the integration. how do we integrate this? So since it's a timer-based function, we have a schedule. This is a cron schedule. So we can schedule when do we want to execute this function at what time. We can specify if there is any input parameter that is required. And in terms of output, we can also see if the function needs to write its output to any of these supported. Then from a management point of view, we have the option to enable or disable the function and also add some keys or security related settings for the host if they are required. So let's look at the monitoring aspect. I've been running this function every day, and we can see that it has succeeded on last 30 days. And in this instance, you can see that there were a couple of resource group with demo prefixed, and they got deleted when the function was executed. Whereas on the other instances, I did not have any resource group, which was having delete me or demo as a prefix, and the function just executed, but it didn't find anything. Let's go back to the presentation. So next we look at containers. So what are the options for running containers on Azure? So first one is obviously the Azure Container Instances, which we can use to run single instance of an Docker container. The next one is Azure Kubernetes Service, which is primarily the use case for multi-container applications. And as part of the demo for this session, I will also show how we can extend Azure Kubernetes Service with the help of a feature called Virtual Node. So let's look at the first case where how we can deploy a container, single container to Azure Container Instance. So here we go to add container instances. We select the resource group where we want to create an instance of a container. We provide the name of the container. Then we will select the region. And in terms of the source of the image where the container image is stored, we can use quick start images, or we can connect to Azure Container Registry, or we can connect to a public registry like Docker Hub. So in terms of quick starts, there are 3 images supported. In terms of Azure Container Registry, I have a container registry, so it will show me what are the images which are available in that container registry. And if I want to connect to Docker Hub as a public container registry, I can provide the repository name and the name of the image here. Then I can also select in terms of the target operating system what I want my OS to be when the container is deployed. And we can select the size for the VM where the image would be deployed. So let's say in this case, I select the quick start image. And then in terms of networking, we can decide, do we want to expose this container publicly, or do we want to deploy it within a private VNet, or do nothing? So just spin it up. So in this case, I will select public as the option. We can also specify which ports we need to expose. So I'm adding 8080 as the port, and we can specify the protocol for exposing that port. And for the advanced setting, we can choose should the container be restarted in case of failure. And it also helps us provide any environment variables. So let's say we have connection string, which is required by the container. So we can provide that as environment variable here. We can also override the command, which is the default command which is executed when the container starts. And once all this is done, we can create the image. So this will deploy onto the Azure Container Instances. So in the interest of time, let me move on to the next demo. And we see the second scenario where we can deploy a function app onto the Azure Kubernetes service. So as you saw, when I created the Azure function in the portal, there was an option to select either as code or as a Docker image. So this is the example where if I want to deploy my function app as a container image onto a Kubernetes environment, I can use this option. So let's see this demo. Okay, before we move there, let me just explain you what the demo is doing. Okay, so this is a function app where I have a storage queue in the Azure storage account, and I have a producer, which is a .NET Core EXE. It produces a configurable number of messages onto this particular storage queue. And I have a AKS cluster, which is having 2 nodes, and there is a Docker image of the Node.js application, which is the consumer of this particular storage queue. So the consumer picks up a message and processes it. And what we want to see is based on the number of messages, we want to scale the consumers up. So that is the demo I'm trying to showcase here. Get started. So currently we can see this is the queue, which doesn't have any items in the queue. And this is the function which has the connection to the storage account. And it's using the access key, account key, to connect to that particular storage queue. In terms of the function itself, the way it's dequeuing, we have index.js, which is a JavaScript function. It picks up one queue item, and just to fake a delay, I'm having a 1 second delay while the message is getting processed, and it processes this after 1 second. So let's look at what is the context I have. So this is the cluster, which is the 2-node Kubernetes cluster I was mentioning. So let's make sure that we have 2 nodes on this. Now let's see the function, which is the API provided, or the function runtime provided by Azure Functions. So here I have the Core Tools 2.7 version installed on my laptop, and we can set different context when the function runs. And in my case, I will be using Kubernetes as the context. That is where I want to deploy this Azure function. And when the function is initialized, I can say I want a Docker image to be created. So automatically a Docker file would be created as part of the function initialization. So now I'm doing a function deploy using a command to deploy this particular function onto the Kubernetes cluster. And I specify some parameters like I want maximum 30 replicas to be created, cooldown period as 10 seconds, and polling interval as 20 seconds. So that means every 20 seconds that the storage account would be checked for queue messages. And if there are no messages for 10 seconds, we would start scaling down the number of replicas. And in the meantime, I also generate 5,000 messages. So you can see here, when I refresh the storage queue, there are some messages getting populated. And I'm also watching the pods and the deployment. So we see the pods and the deployment scaling now on the bottom half of the screen here. So when I run that deploy command, it actually builds my Docker image for the function app, and it also pushes it to the Docker Hub registry. And now I have some instances of that pod running, which consumes the messages. So you can see the message count decreasing. That means the dequeuing is happening. And I'm using a tool called Octant, which gives you the view of the Kubernetes cluster, what's happening. So now you can see here, I have already 16 pods running. And if you look at the deployment, it has currently scaled to 16. And of the 16 images or 16 deployments, 12 are up and running, while the others are getting created. So you can see how fast it's scaling from 1 to 2, 2 to 4, 8, 16, and then up to 30, which is what I set as the limit for my scale. So we can see here that all those messages have been consumed, what were available. The producer is a little bit lagging behind here. So it is still producing the messages while the consumers are up and running. So that's why we see that those messages which are available on the queue, they quickly get picked up. So let's look at one of the pod, which is consuming the messages, and let's look at the logs for that particular pod. And here we can see that the queue which is used, JSQ items, to pick the messages, and we also see the log message that we are writing, which is completed processing. So this is the scenario where I have fixed number of the resources on my AKS cluster. So I have two nodes on the AKS cluster. But let's look at the next scenario, which is what happens if I have, let's say, a case where I don't know what is the load that I'm going to get. Let's take the case of, let's say, Chinese New Year or Deepavali, any event which is going to happen, and you're planning a big promotion and you don't know exactly how many number of people are going to hit your application, or a Black Friday kind of scenario. So in this case, what we could do is we could use what AKS provides as one of the feature is virtual node. So on the screen, you can see a Kubernetes cluster with 4 VMs as an example, initially provisioned, and I can enable virtual node feature for this Kubernetes cluster, and then I can scale and provide all those pods or the workloads onto the Azure Container Instances. And this will scale on the container instances. I can keep my base cluster same, but the scale would be handled as part of the virtual node. So I will use the same example, but now I'm changing my cluster configuration to have a single node Kubernetes cluster, and I enable the virtual node. So let's look at this demo now. So here we can see there are no container instances running at this point of time. So, and in terms of the queue messages, since the producer was taking a bit of time, I started populating about 10,000 messages, and you can see on the right side here, 10,000 messages have been populated. And now I'm changing my context to the virtual node cluster. So when I look for the nodes, you can see that I have a virtual node ACI Linux node added to my cluster here, AKS cluster. So let's start watching the pods and the deployment, and let's go and deploy the application. But I need to make a small change. So I can run this deploy command in the dry run mode to get the YAML file or the manifest file for all the objects which are created as part of my deployment. So let's look at that YAML file, and I need to add a couple of items so that it can schedule the pods on the virtual node. So I'll take some things from backup and just overwrite it in this file here. So I'm modifying two things here. I'm setting the max replica count to 80 and reducing the polling interval to 5 seconds. Default is 30. And in terms of tolerations, I'm adding a toleration saying operator exist. What this means is this particular application or pod can be scheduled on the virtual node if a virtual node exists in the cluster. So now I'm going to deploy the application, and you can see the pods getting created here as well as the deployment scaling. And we will see a slight delay here because on the physical AKS cluster, there are resources readily available, whereas on the virtual node, in terms of creating those pods, we would see a slight delay. So now you can see there are 64 items created, 64 pods, because we have 10,000 messages to be processed. So it is already starting to create about 64. It's reached 80 already here. And if we go back and start looking at the messages, this would start getting consumed as well. And when we look at the container instances, you can see that currently 43 container instances are getting created. You can see the state as pending here. And again, we see the scaling in action. Looks like Reboot is back. So try silencing him. Oh, no, it's not true. So here we can see that these are getting scheduled on the virtual node. And now we can see that the number of container instances has gone up to 78. So this will take those 5 or 10 seconds because of the time we have put in between the polling interval. And at this point of time, all the messages have been picked up, and we can see that we have 77 instances running out of 80. So then with the magic of screen editing, I was able to just shorten the clip a little bit because it took about, I think, 7 minutes or so to complete all the processing. And yeah, you can see here, once all the processing was done, we are scaling back to 0. So now, since there are no messages, the deployment has gone back, and on the left hand side here, you can see the pods terminating. If I go into Octant and I start looking at the pods, you see the count decreasing here drastically as they get terminated. And we should be able to see the same if we go into the container instances in the portal. So let's look at the, okay, so you can see there is nothing left now. Okay. So that's the end of the demos. And in order to summarize, we looked at logic apps, which are workflow-based applications, which allows us to connect to multiple sources. Typically, if you want very low code kind of scenario and you want to connect to SaaS services, you can use logic apps with the designer. Azure Functions are more of a event-based scenarios. If you want to trigger certain action when a particular event occurs, we can use functions. It supports multiple deployment models as well as multiple languages and platforms. And these languages, they are increasing the support for the Azure Functions. So right now we might be having 5 or 6, but we do see support coming for multiple languages as well. In terms of containers, we saw that we could deploy individual container using Azure Container Instances, and we can also containerize the Azure Functions, deploy them on Kubernetes cluster, as well as extend the Kubernetes cluster with virtual node and use the Azure Container Instances along with AKS to handle unpredictable load. So in terms of references, you can have a look at this MS Learn learning path, which is to create the serverless applications. There is also a wonderful resource for Azure Kubernetes service. It's a workshop for about 2.5 hours, covering various things related to AKS, like the cluster creation of the pods, SSL terminations, the monitoring, and all these features are covered as part of this particular workshop. So that brings me to the end of my session. This is the feedback QR code. Please provide feedback, and I open you for any questions if you have. Anybody has any question?
Please see a chat window. Somebody is asking a question.
Okay. Okay, the question is, can you comment on when ACI will suffice and when to use AKS? So as I said, ACI is if you want to use single containers, if you quickly want to run a container, if you want to test it and you don't have a cluster available, you can use ACI. But if you have a microservices kind of application where there are multiple containers within the same application, you would probably use AKS in that matter. But as I demonstrated, you can use AKS plus ACI when you want to scale your AKS cluster, and if you want to have that very short-term burst, let's say your application is expecting very unpredictable response time or unpredictable behavior. You don't know at what point of time you're going to get how many requests. For that kind of scenario, you could use a combination of AKS plus ACI. So you would pay a fixed amount of price for your long-running AKS cluster, but then you will pay for short-term resources, what you use on ACI. Does it make sense if we have only one ACI and we use AKS for scaling? I'm not sure what is the question here. Can you elaborate a bit? Maybe you can enable your mic and you can ask the question. What is the scenario you're
what I'm
asking?
actually trying is that I have one application that is running on the ACI, and I find that is when multiple user using the application, it tend to hang the application. So I was asking whether does AKS come in useful here if I deploy this ACI on the AKS itself.
The virtual node feature of AKS is an add-on. So you will have to enable AKS cluster to have this add-on, and then you can use ACI.
Yes, correct. Because from your presentation, you are saying that the AKS is more for a multi-container. So my question is, if I have only a single ACI, and does it make sense if I go into AKS to deploy the only one single ACI?
Yes, you can deploy one image. So you have only one image for your application, is it?
Yes, correct.
Yes, you can still use AKS for that. ACI is more suitable where you want to do quick testing, I would say. But if you want more scalability and more control, if you want features like monitoring and all other features of AKS, that would be better to have it on AKS.
Okay. Yeah. Okay, I get your answer. Thank you.
Thanks.
Hi, Nilesh. This is Suresh here. Thank you for your question. Your session is good.
My question is the package.
Sorry, can you talk a little bit louder? Your voice is very low.
Is it audible
Slightly better. Yeah, go ahead.
now? Is the container, the package and the container is dependent on the OS, uh, the compatibility of the OS, or it is independent of any OS?
When you build the container, you have a base image, and there is a OS specific version in that. So most of the containers are Linux containers, but you do have support for Windows containers as well. So when you create your Docker file, right, you will specify what is the base image you are using, and that base image would have the OS required for running your application.
Okay, just following that question, I'll give you a scenario also. Just validate me and like I'm writing a .NET Core API and build it in a Docker for Linux. Is it possible for me to load it in the Windows also, or I mean possible to deploy it in a Windows server, or I have to write it everything in a reverse order?
So your question is your Docker image is Linux image. You want to deploy it on Windows.
Yeah.
Windows Server. Uh, Windows Server supports the Windows container. You cannot deploy, as far as I know, you cannot deploy a Linux container on Windows Server.
Okay, yeah, fine, thanks.
Okay, next question is from Naginder sir. So the question is, even AKS nodes can be auto scaled. So what is the differentiation with ACI virtual node scaling? Okay, this is, I think, a good question. So you have the capability of scaling your cluster itself. AKS node has this, AKS cluster has a feature of scaling, auto scaling. The difference here would be the amount of time. So if you enable AKS node scaling, it would take certain amount of time to create or add that particular node to your cluster. And what ACI does is it has this pre-created machines where you can easily deploy your workload. So in terms of scaling, if you're doing the AKS cluster node scaling itself, your workload will not get scheduled until the node is added to your AKS cluster and it's ready to accept the pods onto that. So that might be a factor, the amount of time you require to auto scale your cluster and how much time your the workload keeps running. So in my case, you saw that it took about 7 minutes to process 10,000 messages with about 80 consumers and 78 of those running on ACI. If I had enabled auto scaling on the AKS cluster, it might have taken probably 5 to 10 minutes just to add additional node into the AKS cluster itself. So that's the differentiation, I would say. Next one is what's the difference between Power Automate and Azure Logic Apps from apart from Logic App Ping and Azure App Service, functional and feature wise, when to use which one? I'm sorry, I don't know much about Power Automate, so I'm not able to answer this question. The last one is, in your presentation, I saw you use some software to perform AKS for pods. What is the software? Octant. The UI which I was showing is Octant, and the terminal is Windows Terminal. So if you're asking about the split terminal with four different spaces, that was Windows Terminal. And Girish, you're right. The AKS clusters, the things that I was looking is Octant, the visualizer. No, Octant is not a commercial software. It's like a visualizer for your Kubernetes cluster, not just AKS. Octant is open source. It's not part of Azure. It's like a utility, you can say, which enables you to visualize the Kubernetes cluster. Thanks, Patrick. I see that you're putting a link in terms of logic apps versus functions versus Power Automate. Thanks for that. So I think that's it for now. I will stop here and let Reboot take over.
Hey, I'm sorry if you can allow me for a minute. I just have one question. This is Gurjeet.
Yes.
I was listening all your conversation very carefully. Thank you so much, first of all, for this such a good enlightening session. The one question what I really wanted to understand from you is, we are trying to use this governance service for one of our customer, and that's something we are basically dealing for one of the biggest bank. So the challenge what we are facing at the moment is the volumetric their volume data. So I mean, to be honest, I'll be very honest. We have been trying this implementation since last more than 6 months, and struggling a lot in terms of implementing, because what happens when it comes to basically basically comes to deal with the huge volume data set, it really gives a lot of pain. However, some of my friends, they are using those AWS platform, I think, and they said like they did not get all those experiences. And then I looked at Google, Google as far as a comparison perspective. I found like Google is ahead than Azure. So I just wanted to understand what's the strategy way forward, a strategy for Microsoft to overcome and probably to compete this service for the competitor AWS.
So are you talking about a specific service or you're talking about in general?
No, about this service particularly, it's confined to this one. Maybe cover. I mean, this deployment doctors and components, containerization perspective, basically.
Okay. So you are saying the containers, they are slow on AKS compared to AWS.
Absolutely. That's how we experiencing. We did contact to the Microsoft consular as well. Even though yesterday late night, I had a call with Microsoft Sam. He has seen, but I think he has said there is some problem. I don't know what was. That gentleman said, "Let's give us some time. Probably we need to troubleshoot and then come back to you." So I just wanted to know from your experience, because you have been working so extensively. So did you ever face the challenges? So now we have been the dilemma state. Should we go ahead? Should we think of adopting the AWS for this particular solution? So I mean that's our very point, right? So I just thought to just check with you if you can probably shed some light on it.
Okay, I would say it's a very open-ended question, and since I'm already almost done with the session time, if you don't mind, we can connect offline and we can have a discussion. Yeah, thank you. Over to Reboot.
Thank you, Nilesh. Very closing sessions. I hope everybody enjoyed the session so far.
Absolutely.
We'll make thank you. 10-minute breaks until 13:30. Then we will have another session from how to prepare the environment for the remote worker. So please don't forget to fill up the feedback, and we appreciate your feedback. And